Hello, today we will demonstrate our new feature which allows you to change many signal processing component parameters in real time. This functionality was added to the components that you can currently see on the screen. Components that have an ability to change their parameters are known as tunable components. In order to enable components to be tuned, first we must set up this functionality in Model Settings. In Signal Processing Settings, in the Tunable Components section, we can turn this functionality on, off, or enable configuration at the component level. Now that the global settings are set up, we can set up the components. In order to make the constant component tunable, we have to enable it in its component settings. By ticking the Tunable checkbox, we are now able to change the value of the constant. This makes this component very similar to the SCADA input component. This also works for the gain component, where this ability allows you to change the gain value during simulation. Similarly, if we want to make a sinusoidal, square, or triangular wave source tunable, we have to do the same thing as before. After this setup, we will be able to change all of the parameters that impact the waveforms during simulation: amplitude, frequency, phase shift, and DC offset. The PID controller is also tunable, which means that you can change PID parameters in real time during simulation. Low-pass filters can also be tunable. The cutoff frequency of the low-pass filter can be changed in real time. In addition, there are components which contain low-pass filters in front of them, such as the Park Transformation component and the Single-Phase Phasor component, making these components tunable as well. The Functional Mockup Unit, or FMU component, enables importing models from other simulation tools and has also gained this functionality. In order to make the parameters of the FMU tunable, you have to change the model control settings in the Parameters tab to Tunable. Now, let's check out how to change these parameters during simulation. The simplest way to introduce a widget with parameter change functionality is to simply drag and drop it from the Model Explorer, and afterwards choose what widget you want to use for this purpose. If you enter in the properties of the parameter, you can see that the HIL API function used to access and change these parameters is model_right. You can currently see SCADA with previously set up widgets that can adjust the parameters that were previously listed. First, let's adjust the parameters of a triangular wave according to our preferences. Changes regarding amplitude and frequency can be instantly seen on the scope on the right side of the screen. We can also alter the sinusoidal and square wave source parameters. As already mentioned, values of the constant and gain component can also be changed during simulation. You can see how these changes impact the output of the component's composition on the Digital Signal Output widget. PID regulator parameters are also changeable during simulation, and here we can see how changes in the PID controller parameters impacts the output. Low-pass filter crossover frequency can also be easily changed, whether it's an individual component or it's contained in another component, as it is in the Park Transformation and the Single-Phase Phasor components. You can see how changes in the cutoff frequency impacts the amplitude of the sinusoidal signal on the right screen. In this demonstration, the Park Transformation component converts the voltage measurements in the harmonically rich grid from the ABC to the DQ domain. As you can see, at the moment values after the Park Transformation are highly distorted. However, since we are able to change the values of the low-pass filter cutoff frequency during simulation, we can reject the harmonics instantly. Parameter tuning functionality is the same for FMU import, shown here with an FMI unit. You can see here a screenshot of the simple model imported from another simulation tool via FMI. Just as for the other components, we can change the values of simple elements and observe the output value. Thank you for your attention.